shift, but a move into looking at more, say, aquatic plants or macroinvertebrates. That's really intensive work. So if you can save a little bit of time doing the regular sampling, that's worth a lot of, that's really a good thing. Second is assess the sampling frequency. And again, that was my pointing out, do we have to go out 2 times a month or can we just go out 1 time a month? And finally, number 3, perform trend analysis to determine if water quality since 1997 is getting better, getting worse, or we just can't detect a change for all those bays and those lakes. Any questions so far? Okay. So again, I think the first goal, I think I might have gone into this a little bit, do adjacent bays have similar water quality? So, you could say if 2 adjacent bays have similar water quality, at least statistically, maybe you can sample 1 bay every year, but that second bay maybe every 3 years or something like that to see if there's any changes locally. Again, a lot of resource savings, time, staff, costs could potentially come out of this. So again, bays that were in reasonable close proximity, we clustered those. So we're not going to compare Halstead's Bay to Gray's Bay because they're miles and miles apart. So you'll see on the next several slides how we kind of clustered those. These areas that they, reasonable potential for these bays to mix. So you can see in the southwestern part of Lake Minnetonka, the circles. So we compared those lake monitoring stations together. And, we had 6 of them on different parts of the lake that were seemingly had a reasonable chance of being connected to one another, either through vast open water or through, inlets that go between the bays. So I want to go and explain these graphs, or these tables, excuse me. So in the upper left, you'll see Priest Bay on the sort of the far left. And then, well, if I'm getting film, I'm going to go up here. Is there such a thing as film anymore? Tape? Videotape? So we're comparing Priest Bay in a given year, say 2004, that water quality data from 2004, versus Halstead's Bay. Now, here's Halstead's Bay, and then there's that little gap or little passageway under there. I think it's under 101 or 101, yeah. And then this small area is called Priest Bay. So it's reasonable to assume that there might be some kind of mixing going on there. A lot of the flow of the water in Minnetonka goes this way, and of course goes out the dam. So if we look at total phosphorus for the year 2004 and compare those 2 bays, is there a difference between those values? And for example here, if you see these little asterisks or stars, that would say yes. Statistically, we can say there's a big difference. If there's not a difference between the water quality between those 2 bays, for example, that same year for the Secchi distransparency. So in 2004, you can't tell a statistical difference between these 2 bays. And that's where all this yellow shows up, not significant. So basically, here we're looking at Halstead, which flows into Priest. There's Cooks Bay, West Upper Lake, and then Smithtown Bay. And I think we also had Phelps Bay in there too. So basically, the results said that Halstead's Bay is a lot different than any of the others. It's pretty unique. It's the end of a lot of chain of lakes, especially in Carver County, that flow through 6 Mile Creek down by St. Bonifacius. And you've got that pinch point there where the bridge is. So a lot of what gets into Halstead can stay in there and kind of incubate, grow a lot of algae. Now, Priest Bay flows into Cook's Bay, you start seeing it's still quite a bit different. There's a big difference between this bay and this bay. But once you get out into here, there's really not a whole lot of difference. So that's kind of might suggest that a lot of this stuff is just kind of mixing and blowing around. Well, not blowing around, but just mixing. And you could argue that, well, why would you sample all of these bays when you could just sample one or drop one of them out? And as you'll see later, we'll talk about some possibilities for reducing certain sampling frequencies. For example, this Smithtown Bay, way down where Lake Minnetonka kind of flows down into Lake Virginia, which flows into the Smithtown Bay. And one of the recommendations later on in the talk will be, maybe you can drop this station out and you could almost save 2 to 4 hours a week just getting there, because the boat ramps aren't very close to that one, so you have to travel a long distance and back. So moving on, looking at this, what I call the South Central area, Spring Park Bay, there's a Black Lake in there, Phelps, Carmen, and I tossed in Lafayette because kind of the connection between Carmen and that. And really, I think what really came out of here was that Black Lake's kind of unique. It's very shallow. It's kind of a little passageway to jump around from lake sections of the lake. But Phelps and Spring Park Bay, and to a certain extent this Carmen Bay, it's kind of mixed as well. So there's the possibility of reducing some sampling frequency there as well. So I'll pick up the pace here to we really don't need to go into as much detail. If we look in the northwest part of the lake over near Mound, basically Painter Creek will flow down in through to Jennings Bay, which is quite, does I have it on there? Where's Jennings Bay? Yeah, upper left. It's a lot of those lakes down there, the lower left circle, the northwestern area, they're not very different from one another. They're kind of all mixing together, except for total phosphorus. That's the outlet of Painter Creek, goes into Jennings Bay, and you see a lot of phosphorus in Jennings Bay, but that doesn't seem to be making it down lake into West Arm or Harrison's, which is interesting. I mean, that's one thing that could come out of that. I looked at Crystal Bay as well, because there's kind of that little outlet into Crystal Bay, and it's a completely different system at that point. So if you look at the Crystal Bay, you don't see a lot of yellow in that figure, so it means it's a unique from those other bays, Jennings, Harrison, West Arm. The north central area, Stubbs, Maxwell, North Arm, threw in Lower Lake North and Crystal just for fun. Basically, it says Stubbs is pretty unique. Stubbs Bay is the terminus of Clawson Creek, and then there's a little pinch point, and then you get into Maxwell Bay. So, in a sense, it's showing that Maxwell and North Arm are quite alike, and that's kind of shown here because they're not significant. If you see the yellow, it means those two bays are a lot alike, at least statistically. So again, there's an opportunity to, say, reduce sampling frequency for one or two of those bays. Northeastern area, the Wayzata Bay, Lower Lake North, and also a couple little funny lakes just before the lake, Minnetonka, Tanager Lake, Peavy Lake. Results showing those things are kind of an animal to themselves. They're pretty unique. But Wayzata Bay, Lower Lake North, and then Grays Bay, it's kind of represented here. There's not much difference between all of those. And finally, sort of the southeastern area, Excelsior, kind of wrapping around, a lot of these bays, St. Albans Bay. There are really not a lot of significant differences. And That doesn't necessarily mean that they're mixing with one another, but they could be. It's just that by the time you get to the eastern part of the lake, the water quality is so much better than the other part of the lake, and the values of phosphorus and chlorophyll are pretty low. You can't statistically tell differences between the two. So that's my interpretation of those results. Frequency. The second goal is, again, do we need to sample these lakes, bays twice a month or once a month to assess the health? And again, recall PCA wants you to look at data from June through September, but it doesn't specify how many you should sample. So, you could sample once a month and still assess compliance or impairment. So I thought, okay, we'll look at that. And I want to preface this by saying that earlier on in the talk, I showed some green and blue squares. Some bays, some years had 4 to 7 samples. Some had 8 or more. That's how they had the color distinction. So that gave me the opportunity to say, okay, let's just look at all the data points describe all data points. So early June, late June, July, August, etc. There's your 8 points. And, well, what if I just took all the early points and looked at that data? So we just take all the early ones, so it's 4 data points. Well, what if we took just the late? What if we went out to a lake and just sampled the second half of the month? And the idea was a couple things. Do we need to sample 8 times a year or just 4 times a year? And if so, does it make a difference whether you sample the first part of the month or the last part of the month? So, again, I'm going to walk you through this short one here. This is just Jennings Bay, again, in the northwest part of the Minnetonka, Lake Minnetonka area. Say 1997. If I compared all 8 data points during this summer versus just the 4s at the start of the month of each of those months, or if I compared all those 8 data points versus the last half of the month, or if I compared just the 4 points at the first half versus the last half of the month, again, psychchlorophyll, total phosphorus. No difference. Statistically, it doesn't matter if you sample 4 times a year or 8. That's what this is saying.
What was the 1 star?
The 1 star, that was in 2005 for total phosphorus. It just happened to be that if you sampled at the start of the month versus the end of the month, there was a difference. So, again, and then this one will blind you. Basically, if it's gray, there weren't any data points to compare. If it's yellow, there's no difference. And if you see these little blue stars, that means there were differences. And there was only about a dozen out of, I don't know how many hundreds of comparisons we did. And they all seemed to, I think all of them, except maybe one, were the first half of the month versus the second half of the month. Why that is, I went back and looked and it's like, didn't really show anything popped out. But I guess the point is, the overwhelming majority, and again, this isn't all the lakes. This is, but you're looking at some more rich, nutrient-rich, eutrophic areas like Jennings Bay, but you're also looking at some cleaner areas, Wayzata Bay, and then looking at all 11 upper watershed lakes. So you're going from really clean systems to really, more nutrient-rich systems. I guess the take-home is statistically, it doesn't matter if you sample twice a month or once a month. Finally, the trend analysis. Is a bay or a lake water quality getting better? Is it getting worse? Or can't we detect a difference? And we use 4 approaches. One is just straight water quality data. You go out and collect your sample, you get a data point, that's what we look at. But we were also interested in, well, what if it's a really wet year? Or what if it's a really hot year, or cold year, dry year, wet year? So that's all these other things mean. Data adjusted for runoff or precipitation or temperature. That's what we were trying to see, if there's an effect of temperature on the trends. Kind of adjust for those factors. Then finally, there were those 6 bays, I believe, had some early 1980s data. I thought, well, let's just look at those in the early 80s versus the last 7, 8 years. So, apologize for the smallest here. These are the upper watershed lakes. Again, you can walk through this, kind of just use the straight data, or we adjusted it for runoff, precipitation, or air temperature. And we'll just look at this column. Basically, for Christmas Lake, it's saying the water quality is getting better. From 1997 to 2012, there was a trend there. Dutch Lake, it appeared that there was no significant difference, but a little data looking at certain parts of the data set showed that it was improving. Gleason is improving for phosphorus over that 1997 to 2012 period. Langdon was improving. Again, I have a couple columns here. There's some lakes, some years where you have such a huge outlier that it's like it just wrecks everything, the data analysis. So adjusting some points showed that Long Lake had showed some improvement. Minnetonka, showing a decrease in water quality with respect to transparency, but that didn't really show up in the chlorophyll or phosphorus data. Parley, we weren't able to detect a change, but Pearson's Lake, on all categories, it's improved quite a bit. That was a real success story. Wasserman and Schutz really haven't shown a lot of change, but Virginia showed quite a big increase in the chlorophyll, or the algae, in the water over that time period. If we look at some of the bays in Lake Minnetonka, for the most part, we haven't been able to detect a lot of changes. There's some areas where you've seen improvements in total phosphorus, i.e. phosphorus concentrations going down, say Black Lake, Carson's Bay, Grays Bay, Halsted, a few there. But what was interesting is there's a number of bays where chlorophyll was getting worse, getting increased values. Some of those, it's kind of related to some of these bays are really clean, so to speak, really low algae in the first place. So it doesn't take a very big increase to show a statistical change. So you might go from 10 parts per billion to 12 or 13, over time, and you're going to see a big boost or a significant change. Now, one of the things that's interesting, it's kind of leading into some more study, is your phosphorus went down in Halstead's Bay, but your chlorophyll went up. Typically the thoughts are, you reduce the phosphorus, the algae don't have as much phosphorus to eat or consume, so your chlorophyll goes down. But in Halstead's Bay, that's not the case. And there's some evidence of that in Stubbs Bay as well, when you adjust the data. And I don't see Jennings is that kind of weird bay because it has such high phosphorus in the first place, because it's kind of the terminus of Painter Creek. So that's leading into some work that I'm actually doing right now, and I'll talk about that in a little bit. We're pretty close to finishing up here. Finally, I want to talk about, I mentioned that there's 6 bays where we had a lot of data in the early 1980s, and of course, starting in 97 through the present, we've got a lot of data. So I thought, well, let's just take this block of years here, 7, 8 years, and compare it to the most recent period. And again, you've got some very nutrient-rich eutrophic bays and some very clean water bodies as well. And I think what it really shows is that phosphorus has gone down across the board from very nutrient-rich systems and very nutrient-poor systems, which is very good. Again, PV is kind of an animal to itself. It's kind of just this weird little small lake pocket that's really deep and has a lot of salt in the bottom. It's very, very weird. So again, you see some improvements in water clarity. Some of this might be due to the fact that a lot of the lake's cleaned up a lot since they pointed the sewage treatment plants away from the lake. But the fact that it's being sustained over such a long time and showing that improvement is really, really encouraging. So these are just some examples of, or some suggestions, recommendations that we could reduce the amount of sampling in certain bays in Lake Minnetonka. For example, I mentioned Smithtown. You drop that off the sampling schedule for a year or 2 or 3, or take it out completely. You could save half a day's travel time and effort, and that's really significant. And I have some other suggestions there as well. The sampling frequency, again, you could sample once a month if your only goal is to look at, if one of your primary goals is to look at compliance in the sense of the PCA, looking at those 4 months in the summer for Secchi, chlorophyll, and phosphorus. Trend analysis, upper watershed lake, you see a number of lakes improving, others are stable, or we just weren't able to detect a significant difference. But Virginia is very interesting, that it just seems to be going the wrong direction, and I'd be curious to know why. For Lake Minnetonka, instead of looking at the individual bays, I thought, well, let's just look at by water quality measure, like the transparency. So improving lakes or bays, PV and Wayzata, degrading Wayzata. But again, one of the things with Secchi disk transparency is it doesn't have a huge range of values. You could go down from really bad conditions, half a foot, to maybe 8, 10 feet. That may seem like a big range, but you might have high clarity transparency in June versus really poor clarity when the algae starts growing late in the summer. So statistics, you're comparing these average values. I don't know, like you're comparing 2 bell curves, and if they're really wide and fat, it's hard to tell a difference instead of having, well, I don't know if this does anything to help, but it's just really difficult with Secchi disk transparency to detect changes. For chlorophyll A, again, there's surprising that a number of bays were degrading, but again, as I mentioned, some of them have really low chlorophyll to start with, so they could go from about 8 parts per billion average to 12. You go out there and you look at the lake and it's like, I don't know any different. I can't tell any difference. But I think that's what might be going on there. Or it may be signaling more long-term systemic changes. It's just a possibility. And finally, the nutrient total phosphorus. Seeing a number of bays improving, and it's really good to see Halstead and Stubbs improving. Statistically, we're showing an improvement, which is very encouraging because Halstead, Jennings, and Stubbs are really they've always been the kind of bugaboo because they're the terminus of some major stream systems. You get a lot of runoff, erosion possibly coming in through there. In the Painter system, used to have the Maple Plain treatment plant, processed effluent, eventually working its way down. Degrading PV, and just say any changes. I mentioned that trophic state index, which is kind of an amalgam of those phosphorus, chlorophyll, and Secchi. The only time you really saw changes in that, they were really associated with chlorophyll and phosphorus. So really, using that for statistical tests really didn't show any improvement. And again, looking at early 80s versus the last several years, we saw a market improvement, which is very encouraging. Whether that's due to climate change, whether it's due to the efforts of the district and the cities and the counties. In my opinion, it's like, I don't want to say who cares. It's getting better, but the fact that it is showing an improvement is may suggest that a lot of the efforts to curb the amount of erosion and runoff getting into our lakes is making a difference. Future directions, and this is what I've been doing right now. Well, actually started about a week ago. Is looking at the monthly trend analysis. So looking at the water quality in Wayzata Bay in June of '97, June of 1998, all the way to the present, and just kind of looking, is there one month out of the summer that's really the problem spot, or just see if what jumps out might give us an idea, what type of tactics to take in certain areas of the Lake Minnetonka's watershed or the upper watershed lakes. Maybe we can find that, hey, it's going on in spring or midsummer or late summer. And also, I pointed out that sort of the typical problem bays of Halsteads and Jennings and Stubbs Bay, showing that we're getting phosphorus is going down, but we're having an increased chlorophyll, and those are systems that traditionally had high chlorophyll to begin with. So again, I said I was in progress here, but just kind of a little teaser. This is Halstead's Bay, and I'll explain that here. So up here, this is Secchi or the clarity, transparency, 1997 to 2012. This is the clarity, so higher up in the graph means cleaner, clearer water. The yellow diamonds represent what the values are for the clarity in the month of June through this whole time period. And again, you might only have one or two, sometimes three data points available for a given month. So I didn't put error bars in here because it would look like a Jackson Pollock painting. So what you're really seeing here in Halstead, you got pretty good clarity in June. You've got these are in meters, by the way. So, you've got 7, 8, 9 feet of clarity in June, but in July, that's when things are happening. The clarity's just, and you really can't see much of a difference between July, August, and September, all these stars and X's and triangles. Chlorophyll, that's another thing. It's hard, again, I'm just throwing this up there. I haven't done any really analysis on it. I'm just kind of picking it off here. But you're seeing low chlorophyll, for the most part, these yellow diamonds in June, which kind of corresponds with the high transparency. And then as the chlorophyll goes up, the transparency goes down. Then the question is there a trend in time? Is it getting worse through time? And we showed that phosphorus seems it's trending downward in the case. Chlorophyll is going up. What's going on? It's really strange. It's hard, I have to get in there and dig through that. One of the components of the study I'm doing right now is really actually picking up some work I did when I was still here at the district. I'm like, for example, here, Halstead Bay, Painter Creek comes into Jennings Bay. I looked at, what was the temperature? What was the profile of temperature in Jennings Bay and the creek coming into it? Where was it injecting nutrients? And so I've always wanted to get back to that. I always kept that file. So another component of what I'm doing is not only the trend analysis in all these bays and lakes, but also taking a really close look at the Jennings system, the Halstead Bay system, and the Stubbs Bay system. And finally, I should mention, we've also sampled really deep depth phosphorus in a number of these bays and lakes over time. But sort of the first part of the project, we didn't look at it. So now I'm going to be looking at that. It's a indication of internal loading of phosphorus, which is a real problem in some of the bays. Again, is the phosphorus increasing over time, decreasing? Is there no trend? So it'll help us out in determining how we manage certain lakes and bays where that internal phosphorus is a problem. So I think that's all I have right now. I can take any questions. Go ahead.
Do you have any ideas about this lowering of phosphorus and
Yeah. The only thing one of the things that I'm thinking about is that there was so much phosphorus and so much algae in those, like Halstead's Bay. And if I recall going out there, it was really, the water sometimes could be kind of really dark brown tea colored. A lot of peat, is the wetlands that are coming, part of the 6 Mile Creek system. And maybe some of the efforts by, controlling erosion and runoff getting into the 6 Mile Creek system, which ends up in 6 Mile, maybe that has reduced the phosphorus content, but sort of in an ancillary way has enhanced the light regime in the water. So you still have a fairly large amount of phosphorus in the water. I mean, for example, here in Halstead's Bay, kind of look, we're talking, it's still really eutrophic conditions. You're around 150 parts per billion. Now you're down to 100, and recently. That's still really high, but maybe it's kind of provided some a slight increase in clarity that we can't really detect, and it sort of opened an opportunity for algae to grow. It was like so stained watercolor and sort of murky and dark down there. Maybe it's improving. It's really hard to tell. It'd be nice, hindsight, if we would have measured something like the suspended solids in the water column as well, but that's a lot of work. So, we're going to see what the data is telling us. That's kind of one theory I'm going on.
Do you check this against weather reports? Like a lot of rain, no rain, a hot summer, a dry, cool summer?
Yeah, that was kind of where before we talked about adjusting it or weighting it for precipitation or temperature. And actually, this analysis I'm doing now with sort of the monthly trends are going to do that again. So was it a hot June or cool June? Was it a wet September or a dry September? And just kind of adjust the data and see if that makes a difference.
With the amount of water in the lake, we have a small lake, so obviously water low. It's so easy to tell when we have a lot of water, then the docks are all just even with water. But would it be to say that when the water's higher that there'd be less chlorophyll?
Which lake are you on?
Gleason.
Gleason? Yeah, I think Gleason, I think a lot of that might have to do with it's a reasonably shallow lake, plus dealing with the curly leaf and all that. When you look at how much bounce a lake has over the summer compared to the total volume of water, typically it's not very much. It really doesn't have that great a difference. So, lakes are all alike and lakes are all different. There's just little things. So. I haven't really looked at that. Hadn't looked at that. Wasn't really part of the project. We're just kind of, there's so much data that let's start at this level, and that might be the next level to really start digging in, and if it's temperature, just for sake of argument, if it was temperature that was driving all this, you know, it's like, well, what are we going to do? Put a dome over the lake and air condition it, you know, or heat it? I don't know. So, yeah, it's really complicated. It's nice when things, you know, pop out that are, you know, nice and clear. It's like, oh, okay. And that's what statistics, you know, this initial statistics analysis is trying to tease apart what the heck's going on. So temperature certainly could have an impact. I mean, I always like to say the physical world drives the chemical and biological. It's hard to overcome gravity and temperature. So,
What do you,
well, can we go?
Sure. Just getting back to the first question, the number of sites and number of samples, and trying to think how the conclusions that you've drawn here, namely that in many cases you could get by with fewer sites or fewer samples, does that translate easily to other systems, or what variables am I want to consider if I want to transfer those conclusions? Is that not?
Well,
If it's a shallow, or does this full analysis need to be completed on any system to determine?
I think you'd have to do it on any system. You know, if it was just a single system, it wouldn't take a whole, you know, a ton of effort. You know, obviously here we had 26 bays and 11 lakes and I don't know, like almost 20 years, well, 15 years of data. You know, collecting more, I mean, is something statistically relevant or something ecologically relevant? You know, like I said, some of those bays in the southeast part of the lake, they had such low concentrations, like, you know, if we go from 8 to 10 parts per billion chlorophyll, it's like, ecologically, it's like, what, you know, it's not a big deal. But if you had like a shift in the type of species from some nice diatoms to some nasty blue-greens, that's a whole different ballgame. So did you have a system you're thinking about?
We have a lot of shallow systems.
Mm-hmm.
Polymorphic systems.
Yeah.
So the variability within a given month is so high that I don't know if you ever consider going into a decreasing sampling.
Yeah. I mean, are they recreational lakes? I mean, they're beaches and people's. Yeah, it's be difficult to, you know, transfer the results here to over there, but, you know, if you have a good data record, it could be, you know, could pick it out pretty easily, I think. Go ahead.
I was wondering about the new development in Minnetonka, Presbyterian homes area. Will that make a big difference in Minnetonka Bay with the runoff and contamination and whatever? Or how are they handling that?
Well, with the rules the district has, I don't think it's going to have an impact at all.
No. That was kind of a holding swamp back in there. And
Yeah.
filled that in. Is it all just going to run into the lake?
I think it's, well, you know, I can't really speak to it, but just knowing the district, they're not going to let that happen. You know, they have to control, through the rules, you have to control a certain amount of runoff. So I don't know if anybody here can speak to that, but yeah. But I think you have to capture the first inch of runoff at least. And there's probably treatment trains, you know, like going through swales and rain gardens or something, I don't know. It's got to be an improvement, because I think I remember talking to Mike Panzer once. He said that, you know, when it was a shopping mall, that the parking lot kept sinking. So they'd put another layer of asphalt on it and keep sinking. And then put another layer. So he said, I don't know how thick that asphalt is, but it just keeps going. So, anyway. Approved TMDLs for okay. Well, I guess I guess we're really trying to fit, here we're just teasing apart the data to see, where the problems are in the entire, the upper part of the district with regards to lakes and bays, and really kind of zeroing in on things like where problem areas typically have been, or Jennings, Halstead, Stubbs. But then, as you saw here, Virginia popped out, and figuring out what's going on there. Is there a problem in the channel from Minnehaha down there? There was a pump station on the east end of the lake. Isn't there like a sewage line that goes to a pump station on the west end or east end? Is that leaky? I don't know. Didn't they replace the bridge or some bridge or road over there? It's real, that itself is a complex system. So as far as, teasing apart what's really going on there in the lake versus what's going on outside the lake, I guess continued monitoring over time. I certainly wouldn't suggest reducing the frequency of that lake because it's such a, it's showing such interesting behavior and it's getting worse that, continuing the monitoring, and then I think we got a good grasp on what to do in the watershed to decrease any further degradation caused by the runoff. Some of the analysis I'm doing now is looking at, what's down in the deep waters of that lake? Is it so bad down there that you have to do some type of in-lake treatment, just throwing out there, say, alum treatment or something like that, so that's what might come out of at least the second phase of this data analysis. It hasn't. Yeah. So it, to my knowledge, it's not officially tied to it. Whether it might be in the future, I don't know. Go ahead.
I work at the Fire Lakes in the Watershed
Mm-hmm.
District, and my board has asked me, could we start monitoring every other year? Or, that sort of question. I never really thought about just cutting down to less samples. Do you have any thoughts on every other year versus less samples each year? I know it's one of the few things that you didn't analyze.
Yeah.
Before, but do you have?
Well, just, the data kind of tells you, is it really changing a lot? If it's not changing much, then there's certainly a possibility that you can reduce, the sampling intensity. Again, it's really the data tells you what's going on, and, I don't know what your data set looks like and things like that, but, I think it's, one of the, I want to say mandates of the district here was, in the 10-year plan was, we're going to look at we're going to use this water quality data to look at trends or changes or differences around the district, and never really gotten around to it. So that's what I'm doing, one of the reasons I'm doing it, but I think it's more is not necessarily better. So let's kind of look at a way to, are we oversampling? Are we undersampling? Can we provide some cost savings? Everybody's busy, and there's always new aquatic invasives, aquatic plants, macroinvertebrates. Those things take a lot of time and effort, and so, I think one of the benefits of this project is to see, okay, can we lessen that load, and still get the information we need out of it? And I think we can here. So.
Yeah.
Sure.
Yeah, I just really like that idea of just cutting down the number of samples and seeing that it doesn't change that much.
Mm-hmm. Yeah, there's so much variability, even just pick any lake, there might be an algal bloom in this part of the lake that just kind of started for whatever reason, and it's a lot clearer over in this part of the lake. Well, where did you go out and sample? There's no way you're going to sample you can't go to a lake and sample 50 different spots. That's just impractical. So usually you go to the deep spot, and that's where you do it. So if it can give you the information you need once a month, great. But you need sort of an analysis to see if that's justifiable.
And then do you have this in the report format?
Yeah. Yeah, this first half of it, but this is kind of the second, we call it part 2, pretty original. But good.
Speaking of the variability, you mentioned physical oftentimes you detect trends.
Mm-hmm.
Looking at trends just off August data. Has that been done before? Is that practice this widely?
I don't know it, but I just, plotting some of the data, when I was here, I was out on the lakes pretending to be a grad student. I was like, oh, I remember doing this when I was younger. And I'm like, oh my God. Out on the lake in April, it's raining and blowing, and it's like looking at this GPS, trying to find I went past it. Oh. But no, just being out there, over the summer for a couple summers, and I've actually been to all these locations. You just kind of notice changes, especially in, say, like Halstead's Bay and Jennings and Stubbs and all these lakes. They tend to be clearer in the spring, and then you start getting your algae as it heats up in the summer. So I don't know if anybody's really.
Yeah, I asked because other management agencies tend to look at trend analysis using average oftentimes.
Yeah, so you're probably getting a better estimate of the mean when you look at all those because you got 8 to 10 data points. But they might be 1 point in 1997 for chlorophyll or something like that, and some there might be 3, some there might be 2. So the error around those is pretty. I guess you're putting a lot of faith in the value that you've got up there. So of course, if there's 1 point, you can't. There's no error. It's just 1 point. So anyway, yeah, I hope to pull some good stuff out of here. Go ahead.
When you're evaluating the 4 months, June is typically kind of early in Minnesota, although we did have an early April, May last
Mm-hmm.
year. So July and August typically are your 2 best months for building the normally. If you ever consider just testing those 2 months,
Testing in the sense of.
that's the peak season.
That was part of I think, as part of, again, the MPCA's regulatory compliance, they want those 4 months. Because that's, typically when people are out there, you're going Memorial Day to Labor Day and beyond. But, mm-hmm. Anything else? Well, thanks. Thank you.